All right, today we're diving into something pretty different, a new way to think about building applications. We're talking truly peer-to-peer, no cloud servers, on a platform called Freenet. Let's get into how it works.
But first, let's just kick things off with a big question. What if you built an app and nobody, not a company, not a government, nobody, could ever shut it down? What if it just lived on the network, powered by its own users? That's the huge idea we're going to unpack today.
And to really get why that's such a game changer, just look at this. On the left, that's the internet we know. Apps rely on a central server. If that server goes down, poof, the app is gone. It's a classic single point of failure. But on the right, that's the Freenet model. It's peer-to-peer, which makes it resilient, because the app literally lives on everyone's devices, not in one vulnerable spot.
Okay, so here's our game plan. We'll start with the big vision, then break down the three key parts of its architecture. After that, we'll get into the real magic, how it all stays in sync. We'll look at a real app, see how you'd build one, and then wrap up by asking what this all could mean for the future of the web.
So let's jump right in. Section 1, a new kind of app. This is all about the vision for a much more durable, resilient web.
Now, this is super important. The second you hear decentralized, your brain probably jumps straight to blockchain, right? Well, Freenet is doing something different. See, instead of just being a ledger for financial transactions, Freenet contracts are what you call general-purpose state machines. Think of them less like a bank ledger and more like a shared computer that can run, well, anything. A chat app, a collaboration tool, you name it. And it's built from the ground up to actually scale.
So, how in the world do you actually build an app on this shared computer? Well, it all comes down to this core three-part architecture. This is basically the blueprint for any decentralized app, or DApp, on Freenet.
First up, you've got the contract. The easiest way to think about this, it's the app's public community bulletin board. This is where all the shared info lives, like messages in a public chat room. It runs as WebAssembly, which is a universal code format, and it's spread out across tons of different computers on the network. That means you can't trust any single one of them, so the whole thing is designed with zero trust in mind.
Next, we have the delegate. Now, if the contract is that public bulletin board, the delegate is your private diary. It runs only on your device. It holds all your secrets, like your private keys, it handles encryption, and it's what you use to decide what to post on that public board. This part never ever leaves your machine. It's all yours.
And finally, the part you actually see and touch, the user interface, or UI. This is just a normal web app, nothing fancy here. It's the window that lets you look at the public bulletin board and write in your private diary. It connects locally and securely to the other two parts.
And this table just lays it all out so perfectly. You've got the contract, running out there on the untrusted network, holding the public state. Then the delegate, safe on your trusted device, holding your private secrets. And the UI, running in your browser, totally under your control. This separation of powers is really the key to making the whole thing work securely.
Okay, so we've got these three pieces, but how do you keep everyone's copy of that public bulletin board looking the same? This brings us to the real secret sauce, keeping a distributed state in sync.
Here's the fundamental challenge for any decentralized system. Without a central server acting as the referee, messages can show up in a totally different order for different people. So how does the network agree on what the final truth is?
The answer lies in a pretty scary-sounding mathematical property. It's called a commutative monoid. But don't worry, the concept is way simpler than the name. All it really means is that the system is designed so that the order of the updates doesn't matter. You always end up with the same result.
And this shows it perfectly. Let's say for you, Alice's hello shows up first, then Bob's world. You see hello world. But for someone else across the network, Bob's message gets there first. Because of this special property, when they apply the updates, they get the exact same result. Hello world. The final state is consistent for everyone. It's so clever.
But this whole process also has to be efficient, right? You can't just be sending the entire app state back and forth all the time. That would be incredibly slow. So instead, nodes just exchange a summary, which is like a tiny fingerprint saying here's the version of the data I have, and a delta, which is only the new stuff the other person is missing. It's a really smart way to keep network traffic way down.
All right, enough theory. Let's make this real by looking at an actual Freenet app called River. It's a decentralized chat client, and it's where all these ideas finally click together.
So check this out. For the River app, the contract, our public bulletin board, is what stores the public chat messages and the list of who's in the room. The delegate, our private diary, is what manages your personal keys and encrypts any private messages. And the UI is, you guessed it, the chat window where you're actually typing and reading. See? Each piece has a very clear, logical job to do.
So this all sounds really cool, but how hard is it for a developer to actually build one of these things? Let's take a quick look at how you go from just writing code to having a live, running contract on the network. Now remember that whole complex system of summaries and deltas we talked about? The thing that makes sure everyone's in sync? You'd think that would be a nightmare to code, but the Freenet team has done something kind of magical. They've boiled all that complexity down to one simple line of code. A developer just adds this @composable tag, and a tool automatically generates all that complicated sync logic for them. It's a huge deal.
And from there, the process is pretty straightforward. You build your app in Rust, you publish the compiled code to the network, and you get back a unique key. That key is basically the web address for your brand new, unstoppable application.
Okay, let's zoom all the way back out. What does this all mean? We have to look at both the amazing potential here and the reality of where the technology is today.
We've got to be realistic here. This is cutting-edge stuff, which means it's still early days. The public network is very new and still being built out. Right now, you have to write your contracts in Rust, and the developer tools require a bit of manual work to get set up. It's definitely not a simple one-click process, at least not yet.
But even with those limitations, the core idea is incredibly powerful. By neatly separating the public stuff, the private secrets, and the interface, Freenet gives us a totally new blueprint for building apps. It makes you wonder, are we willing to trade some of the convenience we get from big centralized platforms for the kind of resilience and user control that a decentralized web could offer? This architecture proves it's possible. The only real question left is that a future we're ready to start building?